Hello everyone. Welcome to the Classroom of Advanced Manufacturing Technologies for Welded Structures. I am Huang Bin, and today we will study the fundamentals of plate rolling forming together. I hope that through this lesson, everyone will master the basic principles of plate rolling forming, the process steps, and the methods of quality control. Today's content is divided into 6 parts. An overview of plate rolling forming technology, plate rolling equipment and working principles, core steps of the rolling process, quality control and defect inspection, a moral political case study on rigorous operation and accountability, and a summary with outlook. We will explore each section in detail to ensure you gain a comprehensive understanding of plate rolling forming. Now, let us begin with an overview of plate rolling forming technology. First, let us examine the definition and principles of plate rolling forming technology. Plate rolling forming is a process that uses the friction and pressure of the rolls on a plate rolling machine to bend sheet metal into cylindrical, arcuate, or other shapes. It is widely used in the field of mechanical manufacturing. This process achieves plastic deformation of the sheet by precisely controlling the movement and pressure of the rolls, thereby meeting the shape requirements of various industrial products. Plate rolling forming technology has important applications across multiple industries. For example, in boiler manufacturing, plate rolling forming is used to produce the boiler shell, ensuring it can withstand high pressure and high temperature and guaranteeing the safe operation of the boiler. In shipbuilding, it is used to roll hull segments such as the keel and side shrouds. The quality of these segments directly affects the vessel's buoyancy and stability. Additionally, there are national standards and specifications, such as the JB/T8796 standard, which defines the precision requirements for plate rolling machines, and the GB/T7120 standard, which specifies the operational procedures for the plate rolling process. Next, let us take a detailed look at plate rolling equipment and working principles. Plate rolling equipment is mainly classified into 3-roll plate rolling machines, 4-roll plate rolling machines, and CNC plate rolling machines. The 3-roll plate rolling machine has a simple structure and is suitable for processing medium and small diameter shells. The 4-roll plate rolling machine offers convenient centering and rapid adjustment of sheet position but is more complex to operate. The CNC plate rolling machine uses a high-precision control system to achieve complex shapes and high-accuracy rolling. The working principle of a plate rolling machine is primarily to control the bending radius of the sheet through the movement and pressure of the rolls. For example, in a 3-roll plate rolling machine, the top roll moves vertically while the bottom rolls rotate actively. By adjusting the position of the top roll, the curvature of the sheet changes, achieving different bending radii. The bending radius formula is shown in the diagram. Now we move on to the core steps of the plate rolling process. First, the pre-bending process and its methods. Pre-bending can eliminate the remaining straight edges of the sheet, ensure a smooth transition in the rolled shell, avoid stress concentration, and improve product strength and service life. Pre-bending methods include pressure pre-bending and bending die pre-bending. Pre-bending parameters must be calculated precisely based on the sheet material, thickness, and rolling requirements. The centering process is a key step in plate rolling. Centering prevents sheet skewing and misalignment, ensuring the roundness and dimensional accuracy of the rolled shell. Common centering methods include trough centering and baffle centering. Centering accuracy requirements are determined according to product specifications and usage requirements, generally requiring the centering error to be no more than a certain percentage of the sheet thickness, such as 1%. To verify centering accuracy, measuring tools such as tape measures and universal bevel gauges are used to measure the relative position and angular deviation between the sheet and the rolls, ensuring the centering accuracy meets the requirements. In the bending process, one must consider the choice between cold rolling and hot rolling. Cold rolling is suitable for thin plates and low-strength materials, offering high processing efficiency but demanding high equipment precision. Hot rolling is suitable for thick plates and high-strength materials, reducing processing difficulty but consuming more energy. The calculation and control of springback are also crucial. The springback formula is shown in the diagram. Key quality control indicators for plate rolling forming include roundness control, edge angle control, and end face inclination control. The roundness tolerance generally does not exceed 1% of the shell diameter, and the end face inclination tolerance generally does not exceed 1/1000 of the shell diameter. These indicators directly affect the assembly accuracy and performance of the product. Common defects during plate rolling forming include unprocessed remaining straight edges, excessive springback, and edge angle deformation. Unprocessed straight edges can lead to uneven shell ends, affecting appearance and assembly. Inspection tools include tape measures, universal bevel gauges, and 90 degrees angle squares. Tape measures are used to measure shell diameters and lengths. Universal bevel gauges measure edge angles, and 90 degrees angle squares check end face perpendicularity. Defect remediation methods include correction, repair, welding, and cutting. Quality improvement must start with process optimization, standard operating procedures, and equipment maintenance. Next, we will explore the importance of rigorous operation and accountability through a case study. In a chemical plant pressure vessel explosion accident, improper rolling procedures led to out-of-tolerance shell roundness, which triggered an explosion, causing significant casualties and property loss. Deviations in the plate rolling forming process can cause major accidents, such as pressure vessel explosions and bridge collapses. Operators must develop a strong sense of responsibility and strictly adhere to operating procedures to ensure product quality meets safety requirements. A scientific attitude is key to improving product quality and production efficiency. Team collaboration can fully leverage the strengths of each stage to enhance work efficiency and product quality. Departments must strengthen communication and coordination to form a cohesive quality assurance effort. Through today's lesson, we have studied in detail the fundamentals of plate rolling forming, including the technology overview, equipment and working principles, core process steps, quality control and defect inspection, and the moral political case study. I hope everyone can apply this knowledge in practical operations and continuously improve rolling quality and efficiency. In the future, intelligent plate rolling technology and green manufacturing concepts will become the development direction of plate rolling forming technology. Intelligent plate rolling technology achieves automation and intelligent control of the rolling process through AI-based parameter optimization and real-time defect monitoring. The green manufacturing concept emphasizes energy conservation, emission reduction, and environmental protection. Compared to hot rolling, the cold rolling process has lower energy consumption, higher efficiency, and better product quality, meeting green manufacturing requirements. Talent development needs to focus on combining theoretical knowledge with practical skills, such as mastering theoretical concepts like the springback formula while also possessing practical skills such as centering operations. Strengthen quality awareness and professional ethics education so that operators establish a quality-first, customer-foremost mindset. Strictly follow operating procedures and ensure product quality. This concludes today's lesson. Through this lesson, we have delved into the fundamentals of plate rolling forming. I hope everyone can apply this knowledge to their actual work and continuously enhance their operational skills. This lesson is concluded. Thank you all for listening and goodbye.